All right, it's time to do the January 2019 exam for physical setting chemistry. All right, when you start this exam, you're going to have 50 multiple choice questions first. The first set of multiple choice questions in Part A should be the easiest multiple choice questions. All right, let's get to it. The results of the gold foil experiment led to the conclusion that an atom is. Okay, so first of all, what happened in the gold foil experiment? We had a beam of alpha particles that went through gold foil. Almost all of the alpha particles passed directly through the gold foil. Some of them were deflected. Some of them almost completely deflected back. Okay, so what did that lead Rutherford to conclude? First of all, that there was something that the alpha particles were hitting that had a positive charge, which he determined was the nucleus, and that the atom was mostly empty space since most of the alpha particles went through undeflected. So let's see which one of these answers matches that. So mostly empty space, yes. So that means a hard sphere is definitely wrong. So mostly empty space, yes. And a small negatively charged nucleus or a small positively charged nucleus. Small positively because it deflected the positive alpha particles. Atoms are neutral because the number of protons equals neutrons. Okay, so what is atoms are neutral because positive equals negative. So however many positives you have the same number of negatives. So we have protons that are positive, neutrons that have no charge, protons that are positive, electrons that are negative, neutrons that have no charge. So is it because the positives equal no charge? No. Positives equal negatives? Yes. Protons equals electrons. And the other two don't make sense because we can't have something greater if we're talking about being neutral. In the ground state, the valence electrons of a krypton atom are found in the, this is a quick reference table question. We're going to look up on the periodic table krypton. Okay, and here's its electron configuration, 2, 8, 18, 8. The valence electrons are in the outermost shell. So I'm going to write 2, 8, 18, 8. That's the electron configuration I got from the periodic table. And the valence electrons are found where? I don't even need to know in which specific shell. Outermost shell. According to the wave mechanical model of the atom, electrons are located in, well, the wave mechanical model has a nucleus in the center, and then it has an electron cloud. And, or we can say orbitals. There we go. Which electron configuration represents the electrons in an atom of sodium in the ground state? Well, this is easy. Like we did this for krypton and looked it up. That's all we're going to do is look up sodium. So here's sodium. It is 281. There we go. Ground state is right on the periodic table, so that's an easy question. The elements on the periodic table of the elements are arranged in order of increasing. What is going up as we go across? The big bold numbers, which is what? Atomic number. Which element is malleable at STP? Malleable means the ability to be like hammered into sheets. Think aluminum foil. So that is a metal. Where do we find the metals on the periodic table? Well, we have metalloid touching the staircase. Exception, aluminum is a metal. Metalloid, 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 metalloid. Non-metals, noble gases, non-metal over here. The rest are metals, including these. So we have copper, which let me show you where copper is. Cu. Copper is a metal, right? Right here. At 298 K and 1 atmosphere, which noble gas has the lowest density? Now, if you don't remember, or kind of able to make sense of it, we can just look this up. This is a reference table question. So density is right here. So we'll start with neon. It has 0.000825. All right. Then we have krypton, xenon, and radon. Okay, so here's krypton, 0.003425. And we have xenon and radon left, which they're going to be over here. Here we have xenon, 0.005366. And radon, okay, which is our last one to look it up down here, 0.009074. So which one has the smallest density? Which one of those numbers is the smallest? Which is here. Which two terms represent different types of chemical formulas? Well, our options are empirical, molecular, and structural. There we go. Which quantities are conserved in all chemical reactions? Well, volume, no. Volume is not conserved. Mass, yes. Charge, yes. Energy, yes. Oh, pressure is a no. So here we go. Which term represents the sum of the atomic masses of the atoms in a molecule? So the sum of the atomic masses, well, that is GFM. So it'd be like taking H2O and adding up the atomic masses of the atoms in that molecule. What's another term for gram formula mass? Just formula mass, or remember, the other term is molar mass. All right, let's continue on with our multiple choice. Which equation represents energy being absorbed as a bond is broken? Well, first of all, I can eliminate two choices. Almost every single multiple choice you can eliminate two, because this is forming a bond right here. Forming. So get rid of that. Energy being absorbed as a bond is broken. So just real quick, if we have reactants to products and energy is being absorbed, energy has to be on this side to be absorbed, and energy has to be on this side to be released. So it's this one, right? Okay, let's continue. Which term is used to describe the attraction that an oxygen atom has for the electrons in a chemical bond? Well, that's just the definition. It is electronegativity. Which substance cannot be decomposed by chemical means? So which one of these is an element? How do we know it's an element? A single capital letter. Here. It may have a lowercase letter, but in this case it doesn't. A beaker contains a dilute sodium chloride solution at 1 atmosphere. What happens to the number of solute particles in the solution and the boiling point of the solution as more sodium chloride is dissolved? Well, if we're adding more, it should be obvious that the number of particles increases. So let's get this to a 50-50. So here's the thing. So if we have, this is just pure water, its boiling point is 100 degrees Celsius. When we add stuff to water, like things that aren't water, in order for the water to boil, a liquid water molecule has to leave the solution and become a gas, right? Well, what happens is these solute particles get in the way and kind of trap the water molecules in the solution. So the more particles there are, the more it traps the water and doesn't allow it to escape. So that means the boiling point is going to continue to go higher and higher and higher the more particles we have. So the boiling point is going to increase. Which form of energy is transferred when an ice cube at 0 degrees Celsius is placed in a beaker of water at 50 degrees Celsius. That involves heat, thermal energy. The average kinetic energy of the particles in a sample of matter, that is the definition of temperature. That was an easy one, right? These first 30 multiple choice should be the easy peasy ones. At STP, which gas sample has the same number of molecules as 2 liters of CH4 gas at STP? Well, as long as the temperature and pressure is the same, you will have the same number of molecules when you have the same volume. So, if I had 2 liters of that gas, I need 2 liters of the other one. So, given this equation, which phrase describes this change? So let's do solid, liquid, gas. We can go back and forth, right? And when we go this way, we have to add energy in. So that is endo. When we go this way, energy can leave, and that's exo. So going from a solid to a gas, this way follows the endo arrow. So I know it's endo. And is it a physical change or a chemical change? Well, let's look. It's I2 on this side. It's I2 on this side. Nothing changed. I did not get a new substance. It is a physical change. Which term identifies a factor that will shift a chemical equilibrium? So atomic radius and decay mode, you should know to just get rid of those as options. But we're left with catalyst and temperature. And it may be confusing which one. Well, a catalyst, what it does is it speeds up both the forward and reverse reaction, so it's not going to shift the equilibrium. Temperature is the one that is going to actually shift the equilibrium. According to which theory or law is a chemical reaction most likely to occur when 2 particles with proper energy and orientation interact with each other? So that is collision theory. Addition of a catalyst can speed up a reaction by providing an alternate reaction pathway that has a, so remember, here's a reaction pathway. This one happens to be exothermic. When we add a catalyst, it looks like this. So the location of the product, the reactants and the products does not change, which means the heat of reaction does not change because that's the difference of products minus reactants. So these two are wrong. And what happened, that is activation energy without the catalyst. With the catalyst, it goes down. Okay? Which compound is saturated? Saturated, in this case, means it's full of as many hydrogens as it can hold. If you remember, on the periodic table, we have hydrocarbons. And you can see, as the model shows, only this option holds as many hydrogens as it can. Here, because of the double bond, I can't put another hydrogen on each one. And here, because of the triple bond, I can't put 2 more hydrogens on these carbons. So the only kinds of hydrocarbons that are saturated are alkanes. So it needs to end in A-N-E. There we go. All right, we are almost done with our first easy set of multiple choice questions. An alcohol and an ether have the same molecular formula. These 2 compounds have, well, an alcohol and an ether. So let's just go to table R real quick. Alcohol and ether. Do they have the same name? No. Do they have the same functional group? No. So that can help me maybe eliminate something in my choices. So do they have the same functional group? That's wrong. So they have different functional groups. So because of their different functional groups, the functional group is literally what gives it the properties. So because they have different functional groups, they're going to have different properties. Which metal is most easily oxidized? This is just a reference table question. Where do we go? Table J. Most active for metals means they're the best losers. And remember, Leo means losing electrons. So basically, I'm looking for which one is highest on this table. Well, you can see Ag is close to the bottom, and Cu is close to the bottom. So now I'm left with Co and Mg. Well, clearly Mg is the highest one in that list. Which substance is an Arrhenius acid? Reference table question. And start looking here. And there we go. Which statement describes an electrolyte? An electrolyte is something that conducts electricity when it is dissolved in water. When an electrolyte dissolves in water, the resulting solution conducts an electrical current. Right there. Which type of reaction occurs when an Arrhenius acid reacts with an Arrhenius base to form a salt and water? Acid plus base yields salt and water in neutralization. Compared to the energy released per mole of reactant during chemical reactions, the energy released per mole of reactant during nuclear reactions is, oh my goodness, so much greater. Which phrase describes a risk of using the radioisotope cobalt-60 in treating cancer? Well, when we use radioisotopes, they release radiation. So we are exposing the body to nuclear emissions. So increased biological exposure. All right, now we're moving on to part B-1. These are the harder multiple choice questions. The 3 nuclides are isotopes of uranium because they have the same number of protons, and this is just the isotope definition, different number of neutrons. That's the definition of an isotope. Same number of protons, different number of neutrons. So given this information in the table, diamond and graphite have different properties because they have different what? Well, if they're both carbon, they have the same electronegativities because diamond and graphite are both forms of carbon. They have the same number of protons because every carbon atom has 6 protons. They have the same number of valence electrons because they're carbon. What they have are different crystal structures that give them different properties. Remember, that vocabulary word is allotropes. All right, so given this equation representing a chemical reaction, what kind of reaction is it? Well, let's see. Are we taking 2 things and forming one thing? Not synthesis. Are we taking one thing and breaking it apart? Not decomposition. In order to be single replacement, we need single elements. Do we have single elements? No, we do not. So it is double replacement. A whole bunch of compounds. They just swap places. So see, it was Na with Cl. On this side, it's Ag with Cl. All right, let's continue on. Oops, dropped my reference table. What is the formula for iron 2 oxide? All right, well, iron plus 2 oxide. Let me grab my reference table that I just dropped. What is the charge of an oxide ion? Well, here we go for oxygen. -2. So since this is a +2 and this is a -2, it balances. It is just going to be this. I have to get a charge of 0 at the end, and +2 and -2 does give me a charge of 0. Given this reaction, how many moles of KClO3 must completely react to produce 6 moles of O2? So I want 6 moles of O2. Well, that's what I was given. I want to know how many moles of KClO3, and I have moles of O2 to start. Look at the balanced equation. 2 is the mole ratio, the mole coefficient in front of KClO3. In front of O2, it is 3. So I multiply 6 times 2 is 12. 12 divided by 3 is 4 moles. What is the number of moles of CO2 in a 220 gram sample of CO2? And it gives me the gram formula mass. Well, for this, I need the mole formula. So Number of moles is given mass over gram formula mass. Okay, so moles is mass over gram formula mass. What is my mass? 220 divided by our gram formula mass, 44. So let's do 220 divided by 44 equals 5 moles. A solution containing 25 grams of KNO3 dissolved in 200 grams of H2O. Which numerical setup is used to calculate percent by mass? Well, let's look at percent by mass. It's mass of part over mass of whole times 100. Okay, so I need part over whole times 100. So when I put 25 grams of KNO3 in 200 grams of water, what is my whole thing? Well, the whole thing is both of those. So my bottom needs to be 225. So these are both wrong. And the part is the KNO3. So that's this one. What is the molarity? All right, so I already know it's going to be a calculation. Moles of solute divided by liters of solution. So it's moles divided by liters. That's molarity. How many moles? 0.20. How many liters? 0.50. And let's do that. 0.20. Oops. 0.20 divided by 0.50, right, equals 0.4. There we go. All right, 39. A mixture consists of ethanol and water. Some properties of ethanol and water are given in the table below. Which statement describes a property of ethanol after being separated from the mixture? Well, here's the thing you need to understand. Substances keep their properties in a mixture. So whatever properties ethanol had before, it's going to have after. So non-flammable, well, that's wrong. Melting point of 0, wrong. Density of 0.80, oh yes. And ethanol has a boiling point of 89. No, that's like in between these two. So elements and compounds, it doesn't matter what you make a mixture of, they're going to keep their properties in the mixture. A rigid cylinder with a movable piston contains a sample of hydrogen gas. It gives me a bunch of numbers. Can you tell I need a formula here? What am I going to use? I'm going to use this combined gas law formula. So I'm going to jot it down here because I kind of don't have enough room up here, but I still want to see my number. So P1 V1 over T1 equals P2 V2 over T2. So let's go back. 330 Kelvin is my T1. Pressure 150 kPa. Volume 3.50 equals, what is the volume of the sample at STP? Now I got to go to the reference table again. STP, and my pressure units are in kPa. So 101.3 and 273 Kelvin. So 273 Kelvin, 101.3, trying to find V2. I can cross multiply here, right? So I'm going to write it on this side. 150 times 3.50 times 273 equals 330 times 101.3 times V2. All right, let's kind of combine these terms on this side. So 150 times 3.50 times 273 equals 143,325 equals, and let's combine on that side. 330 times 101.3 equals 33429 times V2. So I need to divide both sides by 33429, and V2 is going to equal So 143,325 divided by 33429 equals, so you can see what I have here, 4.287. So 4.29. And my volume originally was in liters. So let's see what answer choice. Oh, there we go. Which numerical setup can be used to calculate the heat energy required to completely melt 100 grams of water at 0 degrees Celsius? So melting. Another word for melting is fusion. So I use this formula. Q equals MHF. So all I need is mass times something. So these two I know are wrong, right? And HF. I look on the front of the reference table, since I'm talking water, and I look it up. Which one is the heat of fusion? 334. So there we go. During which phase change does the entropy of a sample of H2O increase? So when we have solid to liquid to gas, entropy is disorder. So disorder increases as we go this way. Think about it. Particles are very ordered in a solid, a little bit less ordered in a liquid, and very disordered in a gas. So I have to be moving this way. So going from a gas to a liquid, no. Gas to a solid, no. Liquid to a gas, yes. More disorder. All right. Here's our last page of multiple choice. Given this compound, what is the name? Well, first let's help ourselves by circling what is not carbon and not hydrogen. That's this. So that is going to tell me my functional group. So I go to table R and I look for that in my functional group. No. Okay, well, there's two with nitrogen, and you might get confused, but this one has nitrogen, and there's a double bond O on the carbon, which we do not have. So it is amine. So when you look at the name to see what it has to end with, so amide is wrong. It's amine. And now I have to decide which number is right. Here's what you have to remember. I need the lowest number. So yes, this nitrogen looks like it's on carbon number 4, but flip it and it's on carbon 1. So the lowest number carbon is 1. So given this reaction, what type of reaction? So we have addition, substitution, fermentation, and polymerization. Well, polymerization is an easy one to eliminate. Or C, do we have a giant chain being formed? No. Fermentation is also an easy one to see happening, because do we see an alcohol and carbon dioxide as our products? No, we do not. All right, so we either have addition or substitution. If we have addition, we need to start with usually an alkene. We need to start with a multiple bond. So let's look at this table right here. Here are my formulas. If I take my number of carbons and I double them, that means I have a double bond. If that's how many hydrogens I have, right? If I have an alkane, which means I don't have any double bond, I don't have any triple bond, I take the number of carbons I have, I multiply it by 2, and then I add 2 more to it. So how many carbons do I have? 4. What's double 4? 8. What's 8 plus 2? 10. So that tells me this is an alkane. An addition reaction requires a double bond or a triple bond, usually a double bond. So it's substitution. That means I took off a hydrogen and I put in a chlorine in its place. Which half reaction represents reduction? So I'm just going to draw a quick little number line like we've used a lot. Going this way is Leo losing electrons. Going back this way is Ger. This arrow points to the side of the equation where the electrons belong. So if we have reduction, the electrons belong on this side. So this one is wrong. and this one is wrong. Now we have to decide of these two which one is right. So if we start with Cu plus 2 and we add 2 electrons, would we get Cu? And if we started with Ag and we added 1 electron, would we get Ag plus? Which one makes sense? Which one is balanced? This is positive 2 and negative 2, which would be 0, and it's 0 on this side. This is 0 plus a negative 1, which would be negative 1, and this is positive 1. So this shows no balance of charge, so this is the correct answer. All right, given the balanced ionic equation representing a reaction, which statement describes the electrons involved in this reaction? So remember this number line? Let's look. First, I'm just going to write the charges above each one. So Zn went from 0 to plus 2. 0 to plus 2 follows Leo arrow. Plus 2 to 0. Plus 2 to 0 follows the Ger arrow. So what that means is a zinc atom loses 2 electrons and a CO plus 2 ion gains 2 electrons. So each Zn atom loses 2 electrons and each CO ion gains, yes, that looks right already. So you just have to kind of go through, if they both can't lose, so even if you didn't remember this part, and they both can't gain. So you just had to be able to look at this number line and figure out which one was which. All right, almost done. What are the 2 oxidation states of nitrogen in this compound? Seems like it would be tough to figure out, but what we're going to do is separate it out into these 2 things, which, when I look them up on table E, I can find their charge. So NH4's charge is positive 1, and nitrite, NO2, its charge is negative 1. Okay? So the charge of NH4 is plus 1, the charge of NO2 is negative 1. So I have 1 nitrogen plus 4 hydrogens equaling plus 1. What is the oxidation state of hydrogen? Well, that's one that is easy. It's positive 1. Okay. Unless it's combined with a metal, but that's not a metal. So 4 times positive 1 is plus 4. So nitrogen, and I'm going to subtract 4 from both sides, and I am going to be left with negative 3. In this one, oxygen is negative 2, nitrogen is what I'm trying to find. So nitrogen plus 2 times negative 2 equals negative 1. Nitrogen plus negative 4 equals negative 1, plus 4 to both sides, so that gives me a positive 3. So it seems kind of weird, right? But that its options are going to be negative 3 and positive 3. But there you go. All right, the table below shows the molar concentrations of hydronium ions in 4 different solutions. Which solution has the highest pH? Well, if we look at a quick pH scale like this, we have the most H pluses over here. Over here, we have the most OH negatives. So if it has the highest pH, that's the biggest number over here, it would have the fewest H pluses. So which one of these numbers is the smallest? This one right here. All right, 2 multiple choice left. Given this equation, which type of nuclear equation is represented? Well, beta decay and alpha decay. Those are 2 easy ones to eliminate. So let's look. Beta looks like this. alpha looks like this. If it's beta or alpha decay on the product side, you would see one of those. Do you? No, we do not. Okay, now I'm left with fission versus fusion. Fission is taking a big nucleus, hitting it with something, and it breaks apart. Fusion is taking two little things and joining them together. So this one definitely shows fission. And which nuclear emission has the least penetrating power and the greatest ionizing ability? All right, so the least penetrating power. Well, we can look at the top numbers right here. Least penetrating power, biggest number on top. And here we go. Least penetrating power. If it is most penetrating power, it would have been the gamma ray, but it was least. So there we have it, alpha particle. So that's it. We finished the multiple choice on the January 2019 exam.